The Space Shuttle's solid rocket booster problem began with the faulty design of its joint and increased as both NASA and contractor management first failed to recognize it as a problem, then failed to fix it, and finally treated it as an acceptable flight risk. Morton Thiokol, Inc., the contractor, did not accept the implication of tests early in the program that the design had a serious and unanticipated flaw. NASA did not accept the judgment of its engineers that the design was unacceptable, and as the joint problems grew in number and severity, NASA minimized them in management briefings and reports. Thiokol's stated position was that, quote, "the condition is not desirable but is acceptable," end quote. Neither Thiokol nor NASA expected the rubber O-rings sealing the joints to be touched by hot gases of motor ignition, much less to be partially burned. However, as tests and then flights confirmed damage to the sealing rings, the reaction by both NASA and Thiokol was to increase the amount of damage considered acceptable. At no time did management either recommend a redesign of the joint or call for the shuttle's grounding until the problem was solved. Thiokol was selected to receive the NASA contract to design and build the solid rocket boosters on November 20, 1973. The booster was the largest solid rocket motor ever produced in the United States. It was also the first solid motor program managed by NASA's Marshall Space Flight Center in Huntsville, Alabama. Costs were the primary concern of NASA's selection board, particularly those incurred early in the program. Thiokol's three competitors were Aerojet Solid Propulsion Company, Lockheed Propulsion Company, and United Technologies. The Source Evaluation Board on the proposals rated Thiokol fourth under the design, development, and verification factor, second under the manufacturing, refurbishment, and product support factor, and first under the management factor. Thiokol received the second highest overall mission suitability score, tied with United Technologies. In a December 12, 1973 report, NASA selection officials said Thiokol's, quote, "cost advantages were substantial and consistent throughout all areas evaluated," end quote. They also singled out Thiokol's joint design for special mention. Quote, "The Thiokol motor case joints utilized dual O-rings and test ports between seals, enabling a simple leak check without pressurizing the entire motor," end quote, the official's report said. Quote, "This innovative design feature increased reliability and decreased operations at the launch site, indicating good intention to low cost, design, development, testing, and engineering, and production. We noted that the NASA Source Selection Board's analysis of cost factors indicated that Thiokol could do a more economical job than any of the other proposers in both the development and the production phases of the program, and that, accordingly, the cost per flight to be expected from a Thiokol-built motor would be the lowest," end quote, the official said. Quote, "We therefore concluded that any selection other than Thiokol would give rise to an additional cost of appreciable size," end quote.